All right, I'm going to get started because I'm running a little bit behind, but it should be fairly quick. Run through the slides. My name is Kerrigan. I also work with the guys that were just given the presentation on the tablet stuff. And I'm here to basically talk about display handler, which is first and foremost an awful name. So if anyone has any suggestions for names, I'm more than happy to take those on. Just a quick outline of what I'm going to be covering, basically some background as to why we're doing what we're doing, goals, what we hope to accomplish, some slides on how the design was laid out, some of the features that we have, and some of our future goals. So for the past probably about 4 years, I've been working on a derivative project of what's now OpenXT, but at the time was XT. And we had made a secure compositing technology on top of Surfman, which is in XT and OpenXT. At the time, we didn't have a tremendous access to the source code, so we had to kind of come up with some funky architecture stuff to get as much control of the graphics stack as we could there. And Citrix at the time, we weren't sure whether XT was going to be sticking around. Turned out it wasn't, but we weren't sure if open sourcing was in its future, which thankfully it was. So we had to come up with a contingency plan to have our own display stack that we could kind of move forward with our derivative product, whether XT continued on as a commercial product or if it got open sourced. So we began this back in around the fall of 2013. Kind of took some time to not just jump in and implement. We kind of looked at what existed out there for open source display that we could possibly use. We did some prototyping with Wayland, with DRM, EGL. There was some work done on Mir. But the biggest issue we had with going with a lot of these technologies was there was always stuff that was hanging out in the forefront that we wanted to take advantage of, namely stuff like XenGT, which were not necessarily going to be wholly compatible with any of these solutions. This kind of just goes over that. Plan is always to kind of get this out in open source. Use an LGPL license. We had been in talks with some other graphics companies that had some proprietary solutions that they were interested in linking in, which they have since disappeared. So basically, we went for initial capability was to just use DRM dumb buffers. So we mainly have just 2D support, keep it simple, and kind of get the surrounding bits there so that we could keep the complexity down, but also leave ourselves the wiggle room to get 3D support in the future. We were looking for lots of test cases. We had gone through very ad hoc testing in our previous effort for the secure window compositing. So this time we were trying to take a more methodical approach. One of the biggest things we needed was multi-monitor support. As a very explicit customer requirement. And they wanted to be able to configure those monitors in different ways. And I'll talk about the modes a little later on with some slides to kind of show what they actually are. Monitor hotplugging support in XT/OpenXT was a little wonky at the time. So anytime you were trying to go into a projector or something like that, you were kind of rolling the dice as to whether that was going to work out for you or you're going to end up rebooting. And another goal was basically, say you have rendering technology like XenGT or something like that that you wanted to use, or Virtual. A lot of times you still have to put up an input server. You kind of have to talk to the tool stack. So we wanted to kind of make sure that that was all available and you could go ahead and change your rendering technology as quickly as possible without having to worry about those other details. Some of our requirements were 6 monitors support. We were moving to 4K resolution because that's coming pretty big, and we had to come up with a way where we weren't lagging so far behind in hardware compatibility. We kind of had an issue where our product would come out with a new version, and you couldn't buy any of the hardware anymore. wasn't available. So we were basically had it in our design that we would have to not be playing catch up all the time with hardware compatibility. All right, so just a basic overall design diagram. We have a bunch of different components. I can walk through here. Guest manager is basically the glue between all of our stuff that we have in the display handler and the tool stack. So any bits that it needs to talk to that are tool stack related get filtered through guest manager, which gives us a nice easy way for us to support both OpenXT's tool stack, which is DECVM, and then also using upstream using libxl. Moving on, we have full screen compositor. It's not really a compositor. It's kind of more like a window manager. And this is basically the most basic stub we have in place for that. Right now it just does full screen, but in the future we're looking to do window compositing from the guests and also doing kind of that RDP style window desktop inside of there also. So it's full screen window manager would probably be a better name for it, and hopefully we'll be able to substitute out portions of that code to support different use cases like seamless windowing. Our renderer is also fairly basic on this portion, but the separation there is important. Right now we just do DRM dumb buffers, which is basically just a mem copy. Previously, OpenXT's Surfman has a 0 copy implementation. We moved away from that. The 1 copy did not cause a tremendous amount of performance problems, and it kind of gave us a less maintenance surface area inside the kernel and kind of having to poke around in the i915 driver for every new hardware release. Display manager is a configuration portion, basically talking to how many connectors and displays do you have out there, how you're going to arrange those, and you kind of choose on those display orientations, resolutions, and layout. And then the input server on the right side is a completely new input server from the OpenXT one, and we moved it back into the process space of the display. Although it's not tremendously coupled there, it could be broken out into its own process again. And I have a slide that kind of just will describe how the input server is structured. So that adding new input devices is not a tremendously difficult task. On top of the renderer, you can see there's a kind of an orange box that surrounds that whole thing. The idea is that if you were to change your rendering technology, you would pretty much change that box. And it looks like a lot, but in the case of, say, ZenGT, you would pretty much pull out your renderer, and then the rest of that stack going through the PV backend, the QEMU backend, would pretty much just be replaced by your Intel off-the-shelf drivers. So for the input server, it's kind of a clear distinction between your input sources and then your input sinks. So mainly right now we're using libinput. You can plumb in another input source relatively easily. I would say it's probably 150 to 200 lines of code to throw another input source in there. So if you prefer, say, evdev, or if you wanted to add a VNC source, that's not a tremendously big problem. The sinks, basically different types of guest support, and the input server core is mostly there just muxing where that output goes. So whether it's going through QEMU to the guest, or you have a PV keyboard or mouse driver inside the guest. All right, so overall features, there's 3 modes that currently exist in Display Handler. The extended, so you can share the displays to the guest so that if you have 4 guests and 6 monitors, all 4 guests can basically display to those 6 monitors, depending on which one you're focused on at the time. Clone mode is pretty much what it always is. So you can basically put as many copies of one monitor onto the other monitors. And pinned is kind of interesting. If you have one of these graphics cards that does support, say, 6 monitors, and you had a collection of VMs, you could say that you want maybe 2 of those monitors shared across all VMs, 2 of them dedicated to this one particular VM, and maybe another 2 and 2. So you can split them up and kind of decide who gets to access as many monitors, and you can seamlessly mouse between them. So it's kind of a nice, don't want to say single-pane glass, but kind of like a single-pane glass. So there's extended mode. When you do a VM switch, you can see that you go from a yellow VM to a purple VM. And that's just spanned across 3 monitors. Clone mode is just basically your projector mode that you would normally use if you were given a presentation or something like that. And then this is kind of an example of pin mode where right now there's a purple, red, and yellow VM. The yellow is shared. And you can switch. Actually, I'm sorry. The yellow is pinned. When you do a VM switch, on the right side, that's the shared display. It's going to put any other VM that does not have dedicated pinned monitors. It's going to use that shared display. Inside of OpenXT, we do have integrated, inside of the UI VM, we have a UI for configuring the display. And whether you have dedicated pass-through can also be configured in there if you're doing just PCI pass-through of a GPU. And that way you can seamlessly mouse to those also, which would give you the ability to have a VM with accelerated graphics. So overall, the features, monitor hotplugging was kind of a big deal for us, and it's working out really well. No problem really plugging in laptops and stuff like that to display that. We do also draw a banner on top of the VMs to kind of give you some focus as to what VM you're actually in. So if you were kind of in a corporate environment and you had a VM that was kind of private corporate data, you wouldn't actually be typing some of that into your personal VM where you were doing, I don't know, your eBay shopping or something like that. Also, kind of made things a little bit easier for us, being that we were doing the copy. Our host and guest resolution is completely independent, and that kind of feeds back to the monitor hotplugging support. That makes things easier because you're not constantly mode setting back and forth trying to figure out what is the proper mode to set. Our performance impact is relatively small when we're running multiple screens with multiple HD videos. We're mostly hitting the CPU 5 or 6%. And that scales down. The less you're doing, the less that's changing, it scales down accordingly. We have a parallel task right now where we're working on audio processing to bring that utilization down also. Right now we work on both OpenXT and upstream Zen. Guys before were using it on their demo for this embedded stuff. And then on OpenXT, that's currently our main use case. We have a large swath of unit tests, so each module that's in there is unit tested. We have display drivers for Windows 7 and Windows 10. It wouldn't be a tremendous effort to add Windows 8 support, but none of our customers they're kind of skipping over to Windows 10, and it seems like that's a fairly normal thing right now. We have an FB PV driver that's in place right now, so you can get better resolution support in Linux. And we also have an experimental DRM one that's going to give you multi-monitor support in Linux guests also. And then QEMU guest support is there as kind of a fallback. If your platform doesn't support any of our drivers, you get kind of your basic VGA output. So the resolution is pretty limited. So right now, this is kind of an in-house proprietary thing. We are in the process of open sourcing it. We're going to be starting to build a community. We're going to extend our unit test coverage. And yeah, we need a name. If we were naming streets, Library Street would just be Road Street, Asphalt Avenue or something. And kind of the more interesting portion of this, I think, is once this is all out in open source, is to be able to start integrating some of the more performant rendering technologies that are coming out there for virtualization. GVT-g, we do have somebody who's looking into that right now and integrating that support in there. GL-based renderer, we kind of had planned, but we're thinking about skipping over just because with GVT and Virgil, those seem to be more of a promising path. So it would provide some performance and power savings. And then the Virgil stuff, assuming we can align a little bit with the KVM folks and piggyback off of that, that would be nice to have support in there. So kind of Windows support is pretty important to us. So Virgil kind of presents the challenge of having to write a WDM driver that fully supports all the 3D APIs to a Virgil backend. So GVT seems like the path forward for us in that case. Some of the work that the guys in Embedded are doing and kind of basically expanding the input server to not just the traditional keyboard and mouse that were the main modes of input, because we were mostly a desktop solution. So now adding some of these other sensor data and figuring out how to mux those into guests in a sensible manner. And then we do have some limited gesture support that's built into the display handler. We'd like to get that more configurable at a UI level. Yes. So if we're PCI pass-through to a guest, that guest has complete control of that card. The only thing that display handler is involved in really at that point is input. No, I'm not going to be able to go and scrape out of his, yeah. Mm-hmm. I would certainly. Mm-hmm. I think the interesting thing there is establishing the trust barriers for that stuff. You're passing through each SIROV function to each VM. You're going to have someone who's privileged to start looking at each one of those. And I'm not 100% sure on this, but if whether BTD would get in the way. Yeah, and I don't see any reason why that couldn't be worked into the renderer. Yep. We currently don't have over-the-network support, but there's nothing, I would say, that architecturally precludes that. So if you were to do something, yeah, just as a proof of concept, VNC would be relatively simple to set up. Yeah. Yeah, the G. Yeah, so that, I mean, there was some talks with IntelliGraphics way back when about not doing a remoting solution, but kind of still local and doing some 3D technology stuff. Um, we talked to you guys a couple years ago. Um, you know, uh, more than happy to. Yeah, I can absolutely pass along my contact info, or if you have a couple minutes afterwards, we can talk. Any other questions? All right.